Hello guys, my name is Craig and welcome to Craig Solutions. In today's video, we are going to look at typical exam style questions that have to do with series, and this is the combination of infinite and finite series, and also arithmetic progressions and geometric progressions, and even infinite geometric progressions as well. So, but before we start, please make sure that if you're new to my channel, you press the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So we're going to start off by just jumping straight into the questions. So grab a piece of paper and follow through with me. Okay, so for number one, we've got what? It says the 10th and 20th terms of an AP, that's for an arithmetic progression, are 18 and 88 respectively, right? Find the first term and the sum of the first 16 terms. So for number one, what we know for an arithmetic progression, or what we know about arithmetic progressions, is that the nth term is given by a plus n minus 1 times d, right? And sum of n terms is given by n over 2, 2a plus n minus 1 times d, or it is also given by n over 2, a plus l, like this, or let me put these brackets. So for number one, we're told that the 10th term, u10, is what? A plus 9d, which is equal to 18, right? 18 like this. And the 20th term, u20, which is a plus 19d, is equal to 88, right? So already with just these two equations, we can solve them simultaneously to find a and the common difference d, a being the first term. So solving these simultaneously, as this equation 2 and this equation 1, if we say equation 2 minus equation 1, a minus a will give you 0, then 19d minus 9d, we get a 10d, being equal to 88 minus 18, we get a 70, like this. So d would be equal to 70 over 10, which is 7. So d being 7, that's the common difference. And now finding a, we can either pick any of those to say a is equal to 18 minus 90 from equation 1. Say that a is equal to 18 minus 9 times 7, which is 18 minus 63 to give us minus 40, well, plus minus 45, like this. So a minus 45, this is the common difference. Sorry, this a is the first term that we need, right? So now let's go on to find the sum of the first 16 terms. And I would rather we use this formula, right? So for the first 16 terms, we shall simply find the 16th term, right? Which will be the last term L, because a, we know it already. So it's a plus 15b, which we say a minus 45 plus 15 times 7, right? Let's see what we get here. Minus 45 plus 15 times 7, we get an answer of 60. So the 16th term is 60, right? Such that the sum of the first 16 terms shall be equal to n over 2, which is 16 over 2 times a minus 45 plus l plus 60, which is 8 times 15. And there we get 120. So 120 is the sum of the first 16 terms. Now I would like to move on to number 2. Erase here. Right, so for number 2, what are we saying here? Okay, let me erase that as well. A GP is the first term of 80. So if the first term for a GP, we know that the nth term is given by AR to the power of a minus 1. So U1, which is the first term, A, is said to be equal to 80. And the sum of the first two terms is 40. So first two terms, we know that the second term will be AR. So A plus AR is equal to 40. And now we're asked to find the common ratio and the sum to infinity of the GP. So first of all, we know that A is 80 already. So if you fix out A, we've got 1 minus R being equal to 40. And 1 minus R being equal to 40 over A, such that R is equal to 1 minus 40 over A. Then R will be equal to 1 minus 40 over 80, which is 1 minus a half to give us a half. So the common ratio is R, which is 1 over 2, and okay, now we need to find the sum to infinity. Sum to infinity of a GP is given by A over 1 minus R, provided that the modulus of R is less than 1. So now first term, we know that the first term A is 80 over 1 minus R, that's a half, which is 80 over half, which is 80 over times 2 to give us 160. So 160 will be the sum to infinity of the geometric progression. Now let's move on to number 3. Okay, so for number 3, what do we have? Number 3 says the first and last terms, right, of an AP, that's for an arithmetic progression, are 15 and minus 20. So first term, that's for number 3, first term A is 15, and last term L is minus 20. Question says the sum of all the terms is minus 40. So sum of all the terms which we don't know the number is minus 40, like this. Then our question says work out how many terms there are in the arithmetic progression. So we know that one of the formulae that we can use to calculate the sum, right, of an AP, we say that n over 2 multiplied by A plus L, where n is the number of terms. So here we know that sum of n terms is minus 40. So I say minus 40 is equal to n over 2 times first term A, 15, plus last term L, minus 20. To get minus 40 times 2 being equal to n times minus 5, and minus 80 is equal to minus 5n. And then solving for n, we divide both sides by minus 5, such that n would be equal to 16. So this implies that there are 16 terms in the arithmetic progression. This was for number 3. So now let's continue to look at number 4. Allow me to erase this part. And now for number 4, what are we told? Number 4 says the sum of the first 9 terms of a GP, geometric sequencing, that is a third term of 45 and the 6th term of 1215. Right? It says find the sum of the first 9 terms. So our task is to find the sum of the first 9 terms of the geometric sequencing. So nth term of a GP being given by AR to the power of n minus 1. This implies that the third term, U3, is equal to AR squared, which is said to be equal to 45, and U6, 6th term, which is AR to the power of 5, is equal to 1250, right? And what are we required to do? We need to find the sum of the first 9 terms, which we know is equal to A times 1 minus R to the power of n over 1 minus R, provided that the modulus of R is less than 1. Right? So we need A, which is the first term, and we need R, which is the common difference. The number of terms, we know that n is equal to 9 already. So we need to find A and R such that we substitute in this formula and we calculate our sum of the first 9 terms. So we're going to use AR squared is equal to 45, and AR to the power of 5 is equal to 1250. So if this is equation 1 and this is equation 2, if we say equation 1 divided by equation 2, we're saying AR to the power of 5 over AR squared should be equal to 1215 over 45. Then the A's cancel, R to the power of 5 over R to the power of 2, we get R to the power of 3, and R to the power of 3 being equal to this. We carry out the operation there, divided by 45, get it 27. So r to the power of 3 is equal to 27, and r will be the cube root of 27, which is equal to 3. So 3 is the common ratio, such that to find the first term a, if we use equation 1, a will be 45. Sorry, a will be 45 over r squared, which is 45 over 3 squared, that's 9, which is 5. So therefore the first term would be equal to 5. So now the sum of the first 9 terms, S9 shall be a, which is 5, multiplied by, in this case, since r is greater than 1, we shall use a multiplied by r to the power of n minus 1 over r minus 1. Right? Why? Because in this case, r is greater than 1. So here we will want to get a negative. Right? We definitely will want to get a negative. So we are saying a, which is 5, multiplied by r to the power of n. This is our r is 3, so 3 to the power of 9 multiplied by 1 over 3 minus 1. And let's see what we're going to get. So 3 to the power of 9 minus 1, then times 5, then divided by 2. We get an answer of 49,205. So 49,205. This will be the sum of the first 9 terms for the geometric sequencing. Okay, so this was looking at how we would apply the formulae that we've learned from arithmetic progressions in geometric progressions to typical exam style questions. So please, if you're new to my channel, don't forget to leave a comment, drop a like, and share. Thank you.